We're about to show you some of the best sounding cars we've ever built, and I'm going to tell you right now, not all of it sounds the way I wanted it to. And that right there is kind of the whole point of this video. 18 years, dozens of platforms, Lamborghinis, Ferraris, LS swaps, Corvettes, trucks. And the thing I'm most proud of is not any one single build. It's the fact that when something did not sound right, I always wanted to know why. Because finding out why something did not work is how you figure out why everything else does. And we are walking through 5 builds in this video. A Gallardo, a Ferrari FF, an LS swap pickup, with boom tubes, a C6 Corvette, and a 3rd gen Camaro LS swap that got 130,000 views. Along the way, we're going to talk about X-pipes, steps, megaphones, and why length matters just as much as diameter, and why most people building exhausts are only solving half the problem. If you've been here a while, thanks for sticking around. If this is your first time here, hit the subscribe button and stay to the end because the last section is the one that changes how you're going to think about all of this. I want to be upfront about something before we get going. I am not an engineer, never been one. I'm a BMW step train technician who got curious about why things worked the way they did and has been chasing answers on the dyno ever since. Everything I'm going to tell you in this video, I figured out by doing it wrong first. If there is an engineer watching and you disagree with something, I genuinely want to hear it because I'm still learning, and I'll say that to the day I close the shop. But if you have a car that needs to sound a certain way, or you understand why the exhausts sound like music and why some are just loud, well, you're in the right place. The Gallardo exhaust is where all of this started for me. This was a build that put FMU on the map as exhaust shop, and it's still our #1 seller to this day. And I'm going to be honest with you, when we first built it, I was chasing a number on the dyno. That was it. Somewhere around 30 horsepower at the wheels on an all-wheel drive car. No tune. The number is on the build documentation if you'd like to go look it up. But chasing that number, something happened to the sound that I did not fully understand at the time. It was clearer, it was louder. It had this high-strung character that nothing else available on this platform in 2009 had. And I started asking why. And because that's what I do. So in this video, we're gonna show you 3 different approaches to the Gallardo exhaust: stock Superleggera, LOC system, and ours. And the differences are not subtle. The stock Superleggera uses a chambered muffler with a bypass that dumps almost straight out. No merge. So you're not getting any scavenging benefit from combining the 2 banks, and there's no tonal character from a blended exhaust pulse. Each side dumps out separately and sounds like it. Now, the LOC system uses an X-pipe, and you can see it's radiused, and the point where those 2 pipes meet is tangential. Here's the problem with that design. Air does not want to make a 180-degree turn in a 2.5-inch pipe on a 6-inch radius. And when you force it to do that, the flow separates from the inside of the bend and contracts down. The gas does not fill the full diameter of the pipe because it's trying to go straight and you're asking it to turn completely around in a short distance. Think about it like putting your thumb over a garden hose. The water fans out because you restricted where it was going. It's the same idea, but you're not helping the air. You're making it fight the geometry. That tangential meeting point does create some pressure equalization between the 2 banks, and there is some scavenging from the pressure difference between them, but the energy you already lost in the bend limits how much scavenging is actually doing useful work. Our X-pipe uses a smooth merge, and if you look at the approach angle, each pipe enters at roughly 45 degrees and exits at 45 degrees. The air crosses without making a hard direction change. Flow momentum is preserved through the merge point. And that difference in geometry is a big part of why ours sounds the way it does, and the tangential X sounds the way it does. Now, the LOC system also has these 90-degree balance tubes on it. Short tubes branching off the main pipe at a right angle. The idea is they absorb drone at their resonant frequency, and they probably work for that. But here's what they also do. Think about a jug from a jug band. You blow across the opening depending on what's inside and it makes noise. That's essentially what a 90-degree branch does to your exhaust system. It introduces its own resonant note into the mix, and whatever drone you reduced, you just traded it out for a hollow tone that muddles up the clarity. This is why I do not allow 90-degree transitions on any build. Not one, no exceptions. Now, I want to show you something, and I want to be upfront about it before we roll the clip. This is a Murcielago, and we did this work, and it's an L. The customer came in with a deteriorating center section, and we repaired it and added an X pipe. We used a tangential radius merge. The rear section was not our work, and the angles back there were not great. But I own the X pipe choice. I heard it, and I knew immediately. This is what a tangential X sounds like on a V12. You can pitch the note up some, but you lose the clarity to get it. That car's the reason I've not used that X pipe design really since, except in rare occasions. There's only one design, in my opinion, that gets you both performance and the clean sound together, and that is the smooth merge. Everything else is a trade. The Ferrari FF runs the F140 engine. The F140 engine is Ferrari's naturally aspirated V12 family, and it's been in production in various forms since 2002. It started in the Enzo Ferrari, made its way to the 599, the F12, and eventually the FF when Ferrari launched that in 2011. The version in this FF is around 6 liters, 650 horsepower at 8,000 RPM, and Ferrari built that through 2016. It was Ferrari's first production four-wheel drive car, shooting brake body, 4 seats, and one of the largest naturally aspirated V12s that's ever gone into a production Ferrari. Now that scream a Ferrari V12 is known for, Ferrari is that mostly locked up in the downpipes and the X pipe. That's where all 12 of those exhaust pulses are merging, and you start getting that harmonic character that makes this engine sound what it's like. We had filmed this car with open headers while we had it apart, and you can hear it. All the power's there, the flames are there, but it does not quite have that scream because you haven't merged and blended the 12 cylinders. Once you add the Sport Cats and the smooth merge, it now sounds like this. Now I want to be honest about something. The on-screen text on the black car says full custom exhaust, and I have to own that. It's not exactly accurate. The black car already had an aftermarket rear section when it came to us, and both cars got the same FME work, X-pipe and the Sports Cat, and while the white car has stock rear mufflers. Now, I know what it sounds like when I say that, but I'd rather own it than have somebody in the comments say the full custom exhaust doesn't sound right. The truth is, neither car sounds as good as it could because neither car has the full system. If I ever get a Ferrari V12 in here for a full build, I have a very specific idea of what I would put on it. Custom step midsection, smooth merge X, megaphones, quad canisters and valve, and I think I could give you the cleanest sounding Ferrari V12 exhaust available without a note of the aftermarket tinniness that many manufacturers carry. That would be something. The 52 Chevy Boom Tube truck is a good excuse to talk about something that I think gets left out in a lot of these videos. How a project actually starts here. Now, you don't drop by and ask for an exhaust and we start cutting pipe. That's not how this works. By the time a car pulls into the bay here, months could have gone by since the first conversation. It starts with an email or a phone call, and no, you're not going to get to me on the phone. I'm usually in the shop working with the techs, tuning, diagnosing, planning with Cody, or shooting these videos for you guys at home. I'm lucky to have my mom and my sister handling that first contact, because if I was doing it, I would not be getting the actual work done. If you call, you get a loose ballpark, and I say loose for a reason. Because if you've seen these videos, surprises happen, even on cars I've done before. Then the car comes in for a consultation. We look at it, plan it out, and tighten that number up before anybody touches anything. That's also where we figure out what you actually want. Because when you come here for an exhaust, you're not getting an exhaust. You're getting a result. If you want something that gets attention but still lets you take your wife to dinner without looking like a street takeover, we find that. If you want the most power possible, I can make that happen. And if you want it sleeper quiet with no power loss, we can find that too. And if I say it can be done and it doesn't come out right, I cut it back out and we go again till it is. That happens less often than it used to, but I'm getting better. Now, this customer had an LS swap truck that was just not exciting when it came to the sound. He had cutouts already, but they were not doing enough. The plan was simple: update the valves, move the exit point, and do the boom tubes. Here's something that's worth mentioning. When we did the initial consult in the spring, stainless steel boom tubes as a commercial product were just being planned. Not yet available from Speedy. That wasn't even a thought in my head, and I saw the comments. But by the time the car had showed up in the winter, a few versions existed, but we already set in our approach, and I was happy with how we handled it anyway. The boom tube idea is pretty straightforward. Instead of letting the exhaust dump under the car, you move the termination out and up so the sound actually goes somewhere that you can hear it. A lot of character gets absorbed and diffused by the underbody when it terminates down there, so bring it out and the whole character of the exhaust changes. This was a proof of concept for us, and the versions we played around since then with the boom tubes was more refined. And if you have a truck or something that you want, we can make that happen. So make sure you hit us up in the comments. The Corvette's where a lot of things started coming together. Every tool we have, the steps, the smooth merge X, the megaphones, the valves, the zipper pipe on the loud side, 3 pipes, all in one car. And on this one, we pulled 30 horsepower at the wheels over an aftermarket system that was already on the car when it came in. Not 30 over stock, 30 over a car that already had an aftermarket exhaust. That is a significant number. The LS small block responds very well to exhaust when you treat the whole system as a system rather than just a set of bigger pipes going from A to B. Now, I want to talk about megaphones because I get questions about them constantly. The megaphone, the way we use it, is a stainless device, 14 inches long, starts at about 2.5 inches in diameter and gradually expands over the most of its length to 4 inches and then sharply contracts back to almost the same diameter at the exit. That gradual expansion allows the pressure pulse coming out of the engine to smooth out as it travels through, the same way a collector or an X pipe shapes a pulse. You are turning a sharp spike into something more like a sustained wave. The sharp contraction at the exit sends a reflected pressure wave back towards the engine, and the timing of that reflected wave gives the exhaust valve at a given RPM can shift the power band, and you can benefit where you feel that. And that last part is exactly why I don't push megaphones on street cars as a power upgrade. To actually use that power band shift, you would have to figure out what RPM range you want the power at, and then test placement, install, check the numbers on the dyno, cut it back out, move it, run it again, and repeat until you land where you want. On a race car where you know exactly what corner and what RPM range matters, that process is absolutely worth doing. On a street car where you're running through every RPM on a single drive, you're moving the same power to a range you may not actually use consistently. And I know all this because I did it on a lot of cars. And honest, my conclusion was that the labor cost was not worth it for a street application. On this Corvette and the builds where we use megaphones, they go in for sound and character. They pitch the note up to make it more distinctive. And there is a power gain, but I'm not going to tell you the placement is optimized for the street. That wouldn't be honest. I started figuring out what the LS3 wants back in 2010, and we've done a lot of them since. This build is where that all came together. If you want the ultimate no compromise system for your C6, reach out in the comments. gen Camaro got 130,000 views, and I think I know exactly why. But let me start with the part that almost made this build miserable to work on, the torque arm rear suspension. 3rd gen Camaro, 82 through 92, uses a torque arm in the rear. And here's what that means. Instead of single leaf springs, you have a single arm that runs the length from the axle housing forward along the center line of the car, all the way to the mount in the back of the transmission. And that arm controls the rear axle's movement under braking and acceleration. It's actually a really capable suspension design for the era. Good handling, solid traction under power. But when you want to build an exhaust on an LS version of that car, that arm is sitting right in the middle of where your pipes need to go. Add a modern LS transmission, which is physically longer than the original drivetrain, and now you have the transmission, the torque arm mount, the cross member, and 2 3-inch pipes all trying to exist in the same space at the same time. There's no clean answer. You just find the least bad one and you make it work. Now here's the part that I think is actually why that video worked. Steps. Steps in the exhaust system are exactly what they sound like. The pipe diameter steps up in stages rather than jumping straight to the full outlet size right at the header. And here's what's actually happening at each step. When a pressure wave moves traveling through the pipe, it hits a larger diameter, and part of that continues forward and part of it reflects back toward the engine. Every step you add multiplies the number of waves in the system, and by the time they arrive at the merger or the collector, you have far more wave interactions than you would ever get from a straight pipe. And those interactions, combined with the gradual diameter changes at the collectors and then the merges after, smooth out the sharp pressure spikes. They produce something closer to a musical note rather than a raw pulse from a single cylinder. That's the same physics behind what made certain F1 headers in the late 90s sound the way they did. And it's also why some of the fabricators who built the most musical sounding race headers learned to do it in the 70s before it ever became part of the conversation in Formula racing. The sound part of that is why the video worked. And here's the piece I actually want you to take away from this section. Length matters just as much as diameter. Diameter is what people talk about with exhaust. Bigger diameter, more flow, more power. And that's true to a point. Diameter determines how much exhaust the pipe can carry without choking the engine. But diameter does not tell you what happens when you run that pipe for 18 feet through a tunnel, around a torque arm, through a muffler, past several bends, and out the back. Every foot of that pipe has a friction drag along the wall. There's a thin layer of slower moving gas right against the pipe surface, and the engine has to work against it in the entire length of the system. Every bend adds resistance on top of that. Every transition, every merge, every inch of muffler, heat loss along the entire length that slows as the gas cools, all of that adds up to pumping loss. The engine is spending energy to push the exhaust out rather than make power. And a flow number from the bench test doesn't capture any of that. It's a static measurement of what the pipe can carry in a laboratory. It does not tell you what happens at varying RPM with pressure pulses, with heat loss, or on a real car on the street. Diameter solves one problem. Length creates another. And building a good sounding exhaust means solving both at the same time. Steps are one way to manage that. They let you maintain the exhaust gas velocity earlier in the hotter sections of the system while stepping out to a larger diameter for the final run. You're not jumping to a full size immediately and slowing the gas down before it has enough length to keep moving. The Camaro build is where that clicked for me, and I think it's been part of how I think about every system I build since then.
You're not here for all that. You're here to hear how this thing sounds when we're under load. In the middle of the road, lay into it. It's going to be hard to get you guys a good sound clip because right where this thing wants to make the best noise, it completely loses traction. And that was second gear. Definitely this thing's a screamer, and in third gear I'm getting a little fast. We're going pretty fast there, and I still had another 1,000 RPM. To really hear this thing, I almost have to do it from a dig and light them up, and it's just not going to come across well like it usually does on this channel where we can get the sound clips, but man, this thing is getting squirrely. any sort of RPM I give it to, and I'll just chalk that up to the lightweight and this thing's traction setup for the year. The owner's probably got some things to do to it, but maybe we'll try from a dig just to get you guys some sort of clip. I would say the sound is great, especially from outside, although getting it into the area it sounds great is a little bit difficult, but the chop is mean and the rev is just completely nasty when you're at idle. I'm pretty happy with this thing. The power is excellent as well. Dare I say, almost unusable, at least on this 42 degree Midwest winter day. So obviously tires are an issue, but you know, it is one of those things. If you get this thing to hook up, I bet it's going to sound really nice at the top of the RPM range, but it's just not gonna happen. I'll try it one more time. Man, that sounds mean.
Sometimes I think about what it'd be like if I just didn't care about this the way that I do. Lay some pipes from point A to B, when it sounds however it sounds, tell people that's how it sounds. Move on, do the next one. Build a bigger shop, drive a nicer truck. It'd probably be a lot more profitable. But when someone hears one of these cars and they just get it, they don't say it's loud, they say it sounds the way it should. They understand what we are trying to do. There are bourbon drinkers out there who'll tell you that you don't need anything better than Maker's Mark. And they're not wrong for them, but there's things like Pappy Van Winkle. And when you find the person who can taste the difference, everything makes sense. That's why I do this the way I do it. 18 years of getting it wrong sometimes, getting it right sometimes, and always asking why. Now, if you got something out of this video, share it with somebody who'd appreciate it. Drop a question in the comments, and if you got a project in mind, you know where we are. Stay loud, stay curious, and we'll hear you next time.